Hello guys, my name is Ethan and today we're going to be talking about strong acid, strong base titrations. So basically what a titration is it is a burette, so it kind of looks like this. And then it's filled with either a solution of base or a solution of acid. And basically if it's a solution of base you would put acid in there into the base solution to neutralize it and vice versa. And so basically you want to get the acids in the base to neutralize and get a pH of 7, and then that's your equivalence point. And then so basically today we're going to be finding the pH for the equivalence point and then the end point. And basically you use it would either be like a pH meter or acid base indicators to figure out like the pH. And then after the titration is finished you'll get a titration curve, which can be used to figure out the case of A or the case of B for the acid or base. Alright, so we're going to solve a strong acid, strong base titration. So I have an example problem right here. It says calculate the pH when 45 milliliters and 55 milliliters of 0.1 molar NaOH solution is added to 50 milliliters of 0.1 molar HCl. So to start with, we're going to figure out the molar concentrations of the H plus and OH negative ions. So to start with, we're going to take this number right here, which is 50 milliliters of HCl, so we're going to convert the 50 milliliters to liters, and for sake of time I'm just going to convert it, and so it is 0.05 liters. So in 1 liter there's 0.1 molar H plus, and then when we convert that it ends up being 5 times 10 to the negative 3 mole H plus. So now we're going to do the same for the OH negative ions. So we're going to start with this number right here, the 45 milliliters, and when we convert that to liters, it is 0.045 liters, and in 1 liter there is 0.1 HO negative, and then we get 4.5 times 10 to the negative 3 mole OH negative. So we're going to create an ice table. So the reaction is H plus OH minus creates water. So we got the I, which is initial, then change, then end. So we started with 5 times 10 to the negative 3 mole right here, and then we started with 4.5 times 10 to the negative 3 moles of OH. So we see here that the OH negative concentration is the limiting reactant, so we're going to subtract that. So when we do that calculation, 5 times 10 to the negative 3 minus 4.5 times 10 to the negative 3, we get 5 times 10 to the negative 4. So what we're going to do with that number, now after that we have to figure out the total volume of the solution once all the HCl and the NaOH has been added. So we're going to do 45 milliliters plus 50 milliliters. And we're going to convert those to liters, so we've already done that. So 0.045 liters plus 0.05 liters equals 0.095 liters. So now we want to figure out the molarity. So we're going to do 5 times 10 to the negative 4, which is this number, which is the end concentration. And then we're going to divide it by the total volume, which is 0.095 liters. And this is to figure out the H plus concentration. So when we put that in our calculator, so we already have 5 times 10 to the negative 4. And then when we divide that by 0.095, we get 5.26 times 10 to the negative 3. So now, what we're going to do is we're going to get the pH, so pH equals negative log, and then it's this concentration right here, so we're going to plug that in. So when we plug that in, we'll go negative log 5.26 times 10 to the negative 3, and we get a pH equals 2.28. And so this is the pH for the equivalence point. Alright, so now that we've figured out the pH for the equivalence point, we need to figure out the pH for the endpoint. So we're going to create another ice table with the equation H plus OH negative makes H2O. So instead of using the 0.55 or the 55 milliliters, we're going to use, or instead of using the 45 milliliters, we're going to use the 55 milliliters this time of OH. So we're going to plug that in here, and so it's going to end up being 0.055 liters once you convert milliliters to liters, obviously. And then this is 0.05. And so now, we got to put the ICE. So now H plus is going to be the limiting reagent, so we're going to solve for POH, and then we're going to convert that to pH. So now we subtract the 0.05. So now when we plug that in, 0.55 minus 0.05, then we get 5 times 10 to the negative 3. So now we're going to take that number, or now we have to figure out the final volume of the solution again. So we're going to take the 0.05 plus 0.055, and these are liters, and then we're going to calculate that real quick. And then we get 0.105 liters. So now we're going to solve for the OH concentration. So OH negative concentration equals, so we're going to take the moles, so 5 times 10 to the negative 3, and then we're going to take the volume of the final solution, so 0.105 liters. So now we're going to do 5 times 10 to the negative 3 divided by 0.105, and then we're going to get 0.04762. So now we're going to find the POH. So the POH is equal to the negative log of the OH concentration, which would be this number right here. So we're going to plug this number in. So now we're going to plug that into our calculator. So negative log 0.04762 equals. So now we get a POH of 1.32. So now to get the pH, we're going to have to take, the pH is equal to 14 minus the POH. So now we're going to go 14 minus 1.32. So now we go 14 minus 1.32, and then we get a pH for the end. At the end of the titration, we get 12.68. And so that is how you figure out the pH for the equivalence point and then the end of a strong acid, strong base titration. And make sure you smash that like button, and I'm out.